All right, boys and girls, this is going to be the last video and the last example for today. In example 6, we are going to solve cotangent squared of x plus cosecant squared of x. Oh, I put the square in the wrong place. Minus 7 equals 0. Okay, let me fix that. So basically what you want to do, sorry, I wrote in the wrong place. Basically, what you want to do is narrow it down so that you're working with the same trig identity. So here we have cotangent and cosecant. So either you want to rewrite this as cosecant or this one as cotangent. Okay, I actually find it easy to rewrite cosecant squared of x as cotangent. So obviously that's one of your trig identities. Again, make sure you're using your index cards. But cosecant squared of x is the same as 1 plus cotangent squared of x. Okay? So if I do that, then I can rewrite it as cotangent squared of x plus 1 plus cotangent squared of x minus 7 equals 0. Okay? Again, I just applied trig identity, so I replace cosecant with 1 plus cotangent of squared x. Okay, so now if you look at our equation, we're working all with cotangent, which is really nice. Okay, so our goal is to isolate again the trig identity. So the first thing that I notice I could do is I can combine like terms. Our constants, 1 minus 7 would be negative 6. And then, of course, I can combine our trig identities. So cotangent squared of x plus cotangent squared of x, that will give me 2 cotangent squared of x equals 0. Okay? And let's just keep going because our goal is to isolate cotangent. So I would add, oops, I don't know why I wrote 7. I would add 6 to both sides. And then I'm left with 2 cotangent squared of x equals 6. And then divide both sides by 2. And of course, that would give me cotangent squared of x equals 3. But we don't want to solve for cotangent squared of x. We want to solve for just cotangent. So we're going to square root both sides. And so in doing so, let's see, I'm running out of room over here, so let me move to this side. In doing so, we're left with cotangent of x equals plus or minus square root of 3. Okay, remember, and I showed you guys earlier how we got the plus or minus. So now we're going to solve for it, okay? And again, I'm going to use the unit circle. So surprisingly enough on this one, they didn't give us cosine. We're working with cotangent, so that's really nice, okay? So let me use a new whiteboard so I can show you. Okay, so basically what I rewrote was I rewrote our trig equation here. So our solution was cotangent of x equals plus or minus square root of 3. Again, that's just me isolating it. And then I just wanted to show you a property that we know. We know that cotangent of x is the same as cosine of x over sine of x. And cosine refers to your x values and sine refers to your y values. So when do we get square root of 3? And again, this is just using the unit circle, okay? So we know we're probably not going to be using the points where we have square root of 2 over 2, because if we put those x over y, we're going to end up with 1. So most likely we're going to be using the points that have square root of 3 over 2 and 1/2. But which one? Are we going to be using this one or are we going to be using this one? Okay. And of course it's plus or minus, but I'm just going to stick to those. Well, we know that we have to end up with square root of over 3. So if we want our x value on top, most likely we're going to have to use this one, because square root of 3 over 2 divided by 1/2, it's the same as saying square root of 3 over 2 times the reciprocal of 1/2, which is 2 over 1. And what's going to happen is your 2's will cancel out and you end up with square root of 3. Okay? So we don't want to work with this point. We want to work with this point. And of course, We want square root of 3 to be plus or minus, so we're going to work with the plus or the minus. So now let's look at our unit circle to see when that happens, okay? Okay, so if I graph my unit circle, we know that, remember, this is the point we want to work with, square root of 3 over 2 and 1/2. So that will happen at pi over 6. And then, of course, we don't want these. And then it's going to happen again at 5 pi over 6. And it can keep going. And that's going to happen again at 7 pi over 6. And then that's going to happen again at 11 pi over 6. Okay. And that's going to happen 4 times in one cycle. But again, they didn't put any restriction on our cycles, and remember, these are all infinite. So then let's write a general solution. Okay, so again, just to remind you, it will happen at pi over 6. It will happen at 5 pi over 6. It will also happen at 7 pi over 6. And it'll also happen at 11 pi over 6, okay? But we don't need to write all 4, okay? Because our general solution, I can just work with the first 2. Because then it's just going to be every multiple. So it'll be pi over 6 plus n times pi. And then 5 pi over 6 plus n pi. This is going to be my general solution, because pi over 6 plus 1 pi will give me this one. Pi over 6 plus 2 pi will actually give me this one. And then 5 pi over 6 plus 1 pi will give me this one. And 5 pi over 6 plus 2 pi will actually give me this one. So again, we're just going to keep going in cycles, okay? So if I just work with both of them, it'll just give me every multiple of it, okay? So these are our 2 solutions. Okay, so you have enough to do the checkpoint. And if you feel completely comfortable, then you can move on to today's homework, okay? And again, if you need any help, just reach out.